Hello friends, very good morning to you all. I am Dr. M.H. Annaya, former principal at Dr. Shivkumar Mahaswamy College of Engineering, Bangalore, and presently vice principal at Saptagiri College of Engineering, Bangalore. Friends, in today's session, we are going to learn the development of a triangular pyramid which is resting on its base on HP and is cut by a section plane which is inclined to VP. So it is inclined to HP and normal to VP. So before I start that, we know all that these pyramids have on their lateral surfaces all isosceles triangle. A triangular pyramid will have a triangular base, and on its lateral surface we have three triangles, and all these triangles are isosceles triangles. Now, when you have these, generally the developments of these are drawn assuming that the bottom is open. So if you just cut it open on OA and spread it on a table, you are going to get the development in the form of these triangles, three triangles, OAB, OBC and OCA. You can just observe here the bottom edges, that is AB, BC, CA. They will all be straight edges that can be observed here. They are all straight edges, and these slant edges are all the dimensions. Whatever we mark on the development or the true dimensions, that's an important concept to be remembered by every one of you. Now, let us take this. That is, after we just cut open the edge and spread it on a table, we should get a development like this without any section plane. Now, in today's session, we have a problem on a triangular pyramid having side of base 30 mm. That is, these base edges AB, BC, CA all are having the dimension of 30 millimeter, and the axis is the dimension measured from the center of the bottom face to the vertex. That's called the axis of the solid. That's given to be 60 mm. It's given as 60 mm. So it has to rest on its base on HP with a shorter edge normal to VP. So I am going to place the solid to start with on the HP such that one of the base edges AB is normal to VP, and we obtain the top and front views of the pyramid. You know very well, here in case of the projection of solids, I have taught you that whenever you place any of these cylinders, you will be able to see the base completely and also all the slant edges. So in this triangular pyramid, you will be able to see all the three base edges, namely AB, BC and CA, and all the slant edges OA, OB and OC. So let me start the problem by placing the object to the given condition. So let me mark this XY line and mark VP by HP, indicating first angle projection. We know the top view of this triangular pyramid is going to be an equilateral triangle. I am going to write an equilateral triangle here. Say this is the equilateral triangle, and this has got the dimension of 30 mm. That is specified in the problem. This is 30, likewise all other sides are having 30. Obtain the center of this, that is by bisecting any two adjacent sides, you get it somewhere here. So we will mark this as ABC, ABC, and join the center O to all the corners, because these are all the slant edges which are visible to the observer in the top view. So this is the top view of the pyramid to the given condition, and you know this edge AB is now normal to VP. So the placing of the object is over. Let us get the corresponding front view for the solid. So we have this axis O, the center of the top, that's the vertex, and O1 is the center for the bottom face. So let's get this front view So first of all, let us mark the axis of the solid. So axis is O dash and bottom one is O1 dash, which is normal to HP. And here you are going to get A dash, comma B dash, the edge AB. For C, you write a vertical line from there, a vertical line from here, and then join that. This is going to be point C dash, join O dash to the base edges. So we have this one base edge, the second base edge. The edges are shown here. So we have got completely the front and top views of the pyramid to the given condition. And this height is given as 60 mm, and let's mark it as 60. So this is the height of the object. The front view of the solid, the top view of the solid, both the views we have got here now. And he says in this problem, the solid is cut by a section plane which is normal to VP and inclined at 40 degrees to HP, bisecting the axis of the pyramid. So what is the position? Let's see the position of the object. So this is cut by a section plane which is normal to VP, means normal to the board, and inclined at an angle of 40 degrees to the horizontal, to the XY line, and it has to bisect the axis. What's the meaning of bisecting the axis? That is, it is going to cut or divide the axis into two parts, and we have a point here. I will mark it as 30 mm either from the top or from the base. It's all the same. So now the section plane, whatever I draw, should pass through this and inclined at an angle of 40 degrees to HP. So I just mark the section plane as S1, and that is passing through the midpoint of the axis, which is at a distance of 30 mm from the base or from the vertex. And here, the post generally after the solid is cut, we are going to throw away the upper part and we retain the bottom part, which I show as P. And after that, let me show the retained part of the solid by dark lines or visible lines. So out of the total solid, the section plane has removed this. So we have got only this part to be remaining. Friends, I told you, in case of all these pyramids, cone, cylinder, whatever it may be, the developments are drawn to true size. So every dimension you show on the drawing is a true dimension. Now here we should have this dimension, true dimension for all the edges on the slant edges. So whatever I show as A, B, B, C, C, A, and the slant edges OA, OB, OC, all of them should have the same true length. That is, true length should be same. So what I do is, now I showed you the development without the section plane. We'll have three triangles like this, represented by OAB, OBC and OCA. So all these are two dimensions, and this is 30, 30, 30. Then let's see how to get the true length of the slant edges in this problem. Friends, let us assume first of all that the solid is not cut by any section plane. Hence, the development of this triangular pyramid is going to be we're going to be having three triangles as I'm going to show here. So here, before I draw that, let us see which one of these three slant edges gives the true length, because we have to draw the development for the true size. So first of all, let us see. If you observe OA, OB, they are inclined to VP, so they do not give the true length. Whereas the slanted O dash C dash, whose top view is OC, is the true length, because there is a rule in the projection of the lines. Whenever a line is parallel to VP, the corresponding front view will give the true length. Remember again, I'll just repeat. Whenever a line is parallel to VP, the corresponding front view will give the true length. In this problem, OC is the top view of the slant edge, O dash C dash is the front view. Since OC is parallel to VP, as parallel to XY here, this will give the true length, and generally we represent that as R. R means what? That is the true length. This is the true length R. So I assume that the solid is not cut by any section plane, and over time the development of this using this true length and true length of the base edges. So simply I write a vertical line anywhere to the right side of this. It could be vertical, horizontal, it doesn't matter. So I am going to write the line R. This line I will take and just mark here, and from here, after getting that, I just taking wire the center and this R as the radius, I am going to draw an arc of a circle. An arc is drawn here with wire center radius R. So on this, I told you the base edges are all straight edges. So I am going to have three triangles here. Let me take the compass and make use of that. Make three steps. 1, 2, 3. Each having a length of 30 millimeter because the size of the base edge is 30. So 130, one arc here, center, and the radius 30 mm. Second arc, then say this is the third one. So I am going to take this measurement, means 30 mm. One step, second, third. Join all these to these 3 points by thin lines to start with. This is the thing I have done. Now, like our prisms which you have learnt in the previous sessions, we have to see from which edge or which slant edge we have to start the development. Here I told you, if a section plane is removing either a nautical edge or a slant edge in case of a pyramid, you have to start from there. But in this particular problem, none of the slant edges, namely O dash A dash, O dash B dash and O dash C dash, are not completely removed by the section plane. Hence, we have the choice to start from either A here, RB, RC. So let me start with this is A, this is B, this is C, once again this is A. So we have this and show these, because there are straight edges, join A to B by a thin line, B to C, a thin line, C to A and the thin line. So we have got all these, and each of these are having R, the true length, or is equal to the true length of this slant edge. True length of slant edge. True length of slant edge is marked here. Friends, this is the development of the triangular pyramid without the section planes. Now here we have cut it by a section plane which is inclined at an angle of 40 degrees to HP, and we have to get the development now. So let us start the development from the edge OA and OB. If you observe, friends, the section plane S1 is cutting the slant edges O dash A dash and O dash B dash at this point. Remember, these two slant edges are not true length, and hence this point is to be transferred to the true length line. That true length line is this O dash C dash. So I am going to get the point here. So take this measurement and mark on OA, OA and OB. So I am going to mark this OA, again OA and then OB. You can just take this measurement and make arcs there. Finally, this section plane is cutting the slanted O dash C dash at this point, and this point lies on O dash C dash, which is the true length. So measure this distance and transfer the distance to the line OC. So we are going to get another point here. So we have got the 4 points, 2 on this OA, OB and 1 on OC, and this is repeated because the starting slant edge on the last will be same. So I am going to join all these by straight lines. Remember, friends, for all these solids like prisms, pyramids, cubes, etc., these points have to be joined by straight lines. Only in case of the cones and the cylinders, you have to join them by smooth continuous curves. So I am going to join this to this, join this. So let me name them. So all of you should follow the same sequence. Thereby you will never go wrong. So I am going to mark this as point 1, this as point 2, point 3, and this is point 4. 1, 2, 3. Sorry, it should be 1 because I am OA. It should be the same point. And friends, if you see the front view here, the base of this solid is represented by A dash, B dash, C dash, and the section plane is not cutting this base. Hence, this base is intact. This base is shown in the development by this AB, BC, CA. So, I am going to show this by full line. So, this is intact, this is intact, this is intact. These are intact. Now, after this, see friends, on OA you have got point 1, on OB you have got point 2, 1 comma 2, and on OC you have got point 3, 1, 2, 3 are there. So here, the portion below 1 and portion below 2 is retained. Below portion 1 is on OA, below portion 2 is this part, below portion this 2 is this, and finally on this OC this part is retained, which I am going to show by a visible full line. This is the thing we forgot. Friends, you can observe here, if you represent the retained part as P, this figure will give you P. I will say this as development of P. And there is a term for this solid. Whenever these pyramids are cut by a section plane which is normal to VP and inclined to HP, this part we call it as a truncated pyramid. Similarly, if you have a cone cut by a section plane inclined to the axis, we call that as frustum of a, that is a truncated cone. So here, friends, this figure will give you the complete development of this triangular pyramid resting on its base on HP with one of the short edges normal to VP, and the object is being cut by a section plane which is inclined at 40 degrees to HP and normal to VP. Friends, I hope my session was interesting, and if you find that this is really useful to the students studying engineering graphics or engineering drawing, please subscribe, share the information with your friends, and keep drawing. So have a wonderful day. Thank you very much for viewing my YouTube video. This is Dr. M. H. Annaya signing off.